Here we have a problem on finding derivative. So there is a function here that is y equals to 2x over 3x cubed positive 7, and we have to find the derivative of this function with respect to x. So here in this function we have variable in both numerator and denominator. So whenever I want to find derivative of a function which contains variable in both numerator and denominator, I have to use coefficient rule. What is coefficient rule? Okay, so consider the two variables u and v which are in fraction. So here both u and v are variables, and I want to find derivative of this function u over v. So what should I do? So I have to take the square of the denominator, that is v square. The same v should be taken over here and get the derivative of this u, that is u prime. Now take negative sign and take u, the numerator u as it is, and now get the derivative of v, that is v prime. So this is the coefficient rule to get derivative of a function where we have variable in both numerator and denominator. I'm going to use this coefficient rule in our function to get the derivative. Okay, here in the given function on the left side I have y. So when I find derivative of this y with respect to x, I'll be getting dy over dx. Okay, on the right side I have variable in both numerator and denominator. So I have to use the coefficient rule. So when I use coefficient rule, first I have to square the denominator. So when I square this denominator, I'll be getting 3x cubed positive 7 the whole square. Now I have to take this denominator as it is over here. I get the derivative of the numerator, that is 2x prime. Now we have to take negative sign. Now I have to keep the numerator as it is and get the derivative of this denominator, that is 3x cubed positive 7 prime. Okay, now so 3x cubed positive 7. When I get the derivative of this 2x with respect to x, what will I get? So 2 is a constant multiplied by the variable x. So whenever a variable is multiplied by a constant, and when I want to find derivative, I have to keep the constant as it is, and the derivative of this x with respect to x is just 1. So I get 2 times 1, negative 2x times. Okay, now I have to get the derivative of this 3x cubed positive 7. So here 3 is a constant multiplied by the variable. So I have to keep the constant as it is. And when I want to find the derivative of this x cube, it's very simple. We just have to use the power law of derivative. That is, we have to bring this 3, in front of the variable and subtract 1 from the exponent 3, then it becomes 3x square. That is, the derivative of this x cube is 3x square, and I keep the constant as it is here. And what is the derivative of this constant 7? So whenever we find derivative of a constant with respect to any variable, it will become 0 over, so we get 3x cubed positive 7 the whole square. Okay, here 2 times 1 is 2, and we can distribute this 2 to 3x cubed. It will become 6x cubed positive 2 times 7 will become 14 negative 2x times, and so here the 0 positive 0 can be ignored. 3 times 3x square will become 9x square over 3x cubed positive 7 the whole square. Okay, let's continue over here. 6x cubed positive 14. Okay, now if I negative, and 2 times 9 is 18, and when I multiply this x and x square, it will become x to the third power over 3x cubed positive 7 whole square. Okay, here so 14 negative. Okay, I can combine this 6x cubed negative 18x cubed because both of them are like terms, because both the terms contain x cubed. When I combine negative positive 6x cubed negative 18x cubed, it will become negative 12x cubed over 3x cubed positive 7 the whole square. So here both 14 and 12 are multiples of 2, so I can factor 2 out in numerator. If I factor 2 out, I'll have 7 left in the first term, and I'll have 6x cubed over 3x cubed positive 7 the whole square. So this is the derivative of the given function with respect to x.